Good morning. My name is Faith. I'm a quantity surveyor from Kenya, and I'm going to take you through my thesis, which I was researching on integrating BIM models and AI for cost estimation. So what I'm going to take you through is a proof of concept of integration of artificial intelligence. And we know that cost estimation is a critical part of project management because it guides the budgeting and decision making throughout the project phases, from the preliminary design to handover. And one of the challenges with traditional cost estimation in construction is that there is limitation due to complexity of design, the accuracy that is demanded therein, and the tight schedules of project. And since cost estimation involves manual processes, which involves taking information from cost databases, documents which are written in natural language, and connecting it to geometric data, this process sometimes is slow and susceptible to errors. And despite advancements in BIM, I know that where you'll see much later on, AI enhances information retrieval from BIM models through automation. So our focus is going to explore BIM-based quantity takeoff and the potential to automate identification of cost elements. This is because cost is data intensive, and even with semi-automation of BIM, that BIM comes with, there is need to merge information from various sources of both the model cost elements and the market prices to achieve accurate estimates. So we're going to check on the effectiveness of AI and also conceptualize a framework for integrating AI for quantity takeoff and cost estimation. So the first step to be able to achieve this is to classify data. So as I said earlier on, that cost element and cost estimation involves a lot of data. So for automation to be implemented, we'll go through information classification, define the semantic and ontology, annotate the text, and further refine before it can be integrated into BIM models. And information classification involves creating cost information classes to establish diverse relation between cost items based on its domain and the geometric domain. And the principles behind the classification of this information is based on 4 key domains, which is the construction results. This defines the finished part of the classified according to the function. For example, partition wall, window. Construction process, this involves the construction activities sorted according to the type of material. This could be structural steelwork, masonry work, carpentry work. Construction resource, this involves separate tables for classification of buildings and building machinery, such as marble, and then eventually its characteristics. Once the information has been classified, then semantic and ontology is defined, and this text is annotated using an open source data labeling tool called Channel. The annotated text is based on natural language cost elements, but with reference to IFC cost item. IFC cost item represents an entity categorized under the IFC control and functions as a representation of the cost-related elements, including service costs, work execution costs, life cycle costs, budgets, asset costs, and these parameters affect the price. The parameters that are affecting the price are extracted from this description and form the main part of reference from the database. Well, this is just a structure of the IFC cost item ontology. And once the text has been classified according to the IFC cost item, text refinement is further done to consider different users. In my research, I was basing it on the base of geographic areas, such as the users who will define a column as a pillar, and some will define it as a column. So we'll standardize this to be identified as an IFC column or beams and girders to avoid any kind of confusion. So the outcome of this phase of text refinement reduces semantic ambiguity and results in the creation of a common environment where all data related to generating a cost item are stored in a relational database. So all the steps that I've been defining here, from information classification, semantic and ontology definition, text annotation, text refinement, is what will form the text database. And then now, to introduce artificial intelligence, I went with the concept of large language models. I am sure each one of you has interacted with ChatGPT at one point in the recent past. So the steps that we are going to follow is you're going to use the cost database that has been properly annotated to refer to IFC elements and integrate it to large language models such as ChatGPT or any form of chatbot to extract information for cost elements. And the LangChain framework for these large language models is designed based on two fundamental principles. This is data awareness, because of the data that we will refer to it. And its data-aware nature allows seamless connectivity between language models and sources of data, enabling comprehensive analysis of cost information. And then the other principle is the automated capabilities. This agentic capability from LangChain empower the models to interact intelligently with the BIM model. Now, this is what happens when data is ingested into the large language models or the AI model. The cost database that was properly annotated is split into chunks to create a mathematical representation of the data, which is easily readable by the artificial intelligence tool. This captures the relationship between different words or phrases and represents the complex metadata in a simpler form. And then it's stored in a vector database to allow efficient searching of these embeddings. And to be able to retrieve the data that was ingested, it's the common way that you would use a chatbot. Like, you will input your query, and then on the large language models, it will give you the answer. But on the background, it will do similarity search. As I'll give you an example of columns and pillar, it will do a similarity search from the vector store, the vector database, and retrieve relevant chunks here and give the response that you need. So the large database has been vectorized and can be used in the large language models to retrieve only the information that needs to be referenced. So the current process of BIM-based quantity takeoff, this is a typical workflow of the BIM-based quantity takeoff, as is where the federated model is input into a tool, and then quantity takeoff is generated and manual reference to existing cost database is done. But this section of this process is where is automated with the large language models and artificial intelligence, as we will see. So ideally, this is how the tool works, where you as a user, you will input project parameters in a BIM authoring tool to come up with a federated model, and then input it into the cost estimation automated system, where it will give you, from the natural language user prompt that you will ask or query it, it will give you the response for it. And previous information or similarity search is done and stored in the database storage for further refinement of the text. Well, here is an illustration of how this will work. Can you see?
Yes, we can.
Yeah, so ideally here is me as the user inputting queries about cost elements of the BIM model, which we loaded into the system, and automatically it retrieves information from the models on elements on the quantities of every other element that is required based on the query that I input into the chatbot or into the large language model. In the interest of time, From the illustration, well, if it is slowed down, you will notice that there is accuracy of semantic parsing of information, where one of the prompts that I input there is what is the floor finish of the master bedroom. Annotated value from the text that I had shown you previously, where annotation is done, was floor, and the cost as item that is required to retrieve is the floor finish, which is a property set. And then the retrieved value is ceramic tiles. Another input that I input there is on provide the thickness of the plaster of the internal wall, and the annotated value is thickness. The quantity set is the plaster thickness, and it gives the retrieved value of 25 millimeters. Well, this is an illustration because I told you earlier that this is a proof of concept. And from whatever I have just illustrated here, it shows that AI can be integrated with BIM cost elements and cost database and significantly reduce the time taken for estimation, simplifies the complex task that goes behind retrieving information for cost estimation, and also this is a departure from the traditional methods, which reduces reliance on specialized technical expertise. And also different stakeholders can retrieve information from BIM models regardless of their background. I also highlighted the strengths, weaknesses, opportunities, and threats of this. And one of it, of course, is time efficiency. The artificial intelligence tool reduces manual calculation time and quickly processes large data sets for faster estimation. Its scalability also, because it can handle complex models, regardless of any type of model, so long as the model has proper metadata, it can be handled by the tool. Part of the weakness is that it heavily relies on the data quality. The cost data is essential, and therefore it has to be properly classified and annotated properly. And also one of the challenges that I also encountered as an individual is the cost data availability, because there is limited historical cost data available. And I had to approach probably contractors or construction firms, which we know that this is their bargaining power, and it's therefore not easily available to have the cost data. However, this can enhance decision-making. Accurate AI estimation support better decision-making by providing insights into the project feasibility and resource allocation. And then also some of the threats is the ethical consideration, because this is a challenge that is being discussed in the AI space, even with the ChatGPT. How sure are you about the data privacy of your information once you input it into AI models? Well, future work that I will propose for this case is integrating such a system into BIM authoring tools and shifting from the autonomous loading of the federated model. This is to imply that for this system, I loaded the BIM model into the system in order to query it, but future development will involve integrating artificial intelligence into BIM authoring tools right at the point of design. And then the framework will also be developed further to generate comprehensive cost estimation reports in various formats such as PDF, Excel, and therefore improving construction project management practices. I believe I have kept time. Thank you.